Okay, so here's how this works. In terms of frequency and period, because they're both related to each other. Remember, the period of a graph is how far it travels horizontally, or how far it has to go in the x direction to complete one cycle. Okay, so it's basically saying the distance you travel within a certain length of time, that one period. Frequency and periods are just reciprocals of each other. So frequency is 1 over the period. If you can figure out what the period is, you flip it, you got the frequency. The frequency is telling you how long it takes to complete one cycle. That's like what this would translate to if you're doing it. So this is so how long it takes to one cycle period. All right, so it's like the length of time it takes to complete a cycle or a period. That's what the with the way this function is, it's already written out for you. Everyone should be able to figure out what the period is. Because here is the number I'm focusing on to get the period. That would be like the b that we've been working with. So I know that for this function that's up there, the period should be 2 pi over 20 pi, which is 1/10. Okay? So for part A, for me to get the frequency, if I know what the period is, I just have to do the reciprocal of that, which means flip it, to get what the frequency is. So the frequency should just be 10. It's word problems, make sure you put units with it. Frequency is always a measurement of time. So since they say the time is in minutes, the frequency would be 10 minutes, which means it takes it 10 minutes to complete whatever the cycle is going. All right, so for part B, when I do the sketch here, I've already got the period listed out. There is a shift to this, so we'll draw it like this. X, Y. Okay, so my period is going to start at the farthest end, just like I would always do it, right? One period is the mark that's out here, that's 1/10. The first mark is 1/4 of that, so it'd be 1 over 40. This would be 2 over 40, but you always want to write these reduced, so that's 20, and then that's 3 over 40, and that's 1 over 10. Okay, for the up and down portion, right? The up and down portion, the y-axis is related to this number, right, which would be my amplitude, the 0.2, correct? Yeah? Okay. And then this number out here, it's not grouped like with the variable, like there's no parentheses around it. So if there's no parentheses, this is standing for a vertical shift, not a horizontal one. Okay? So in terms of me drawing this out, I've got a vertical shift of 8, which remember when we dealt with this, I said what you should probably do is take the axis it normally passes through, which is this, and just shift it up to 8. So instead of going through y equals 0, you're now starting it at y equals 8. So this would become like the fake x-axis if you were graphing. And your amplitude would now be the distance from this line. So that means that the highest it goes up to would be 8.2, because you got to add the amplitude to it and then subtract it. So actually when I draw it, it's just going to be within that range. Okay, and I think right there, yeah. And right here, I've already got the answer for C. The C is just saying find the maximum. You could probably stop right there. Maximum displacement meaning how high it's going, which is that number. So this number right there is actually going to be what C is, the 8.2. But again, I'd be putting like a label with it with units, so this would be in meters. Let's see, to finish sketching this, cosine starts, does cosine start at the middle line, or does it start at the highest or lowest? Highest. So I'm starting here, there, there you go. So that'd be B, C would be, what did I say, 8.2 meters. you guys are either picking sine or cosine graph. You're not writing secants, cosecants, tangents, so on. The last thing they say there, where it says assume displacement or whatever, that's how you're going to decide if it's sine or cosine. Okay? All right? Meaning, like, my base sine graph, like sine x, is like this. Right? Cosine x, and its base goes like that. Okay? So when I mean like the last portion up there tells you what to pick, when it says here, assume displacement at 0. So when they say at 0, they're saying at this point right here. All right? When it's saying at displacement is 0 at time t equals 0, they're saying that it's starting at the middle. All right? If they said something like displacement was a maximum, that would be more related to this. So if it says starting at 0 at time is 0, because this is t equals 0, then you pick sine. So like this would be a sine function because you're starting at the 0 point. If it said starting at a max, or if it said starting at a minimum, then it would be a cosine graph. Cosine. Wait, how to have you see? So now, like, I kind of mentioned to you guys already that you're not really going to be dealing with horizontal shifts here, not for coming up with equations. So I can have my 3 things written out that might be affected here. This would be the vertical shift, amplitude, and then the number that affects the period. Remember, you don't take what they say the period is and put it in place of b. What you got to remember is things like the period is 2 pi divided by b. Okay? This is the only one you kind of have to do a little work on, because amplitude should be whatever the heck they say it is. Okay? Like here it says, what's the amplitude? 24. So I know that since my amplitude is 24, I know A is going to be 24 when I put it in. Right? If they give you the period, in reality what you're doing is you're setting this equation up, but you're putting a number in here and finding that one. So if I were to solve this out, like if I had a number here, like what's the period they tell you? 2. So it'd be set up like that. So if I were to solve for B, it's basically like you reverse those positions. So B ends up being 2 pi divided by whatever they say the period is. So what's 2 pi divided by 2? So I know B is pi. Okay? The only other thing might be a vertical shift, but they don't mention anything about like the maximum displacement or minimum displacement being different than the amplitude. So based on what they have up there, I would just have to assume that this is non-existent in the problem. So I just got to take the 2 numbers I have, put them in there. So the equation for this one would look like 24 sine pi t. So that'd be the whole thing. So again, just don't make sure you're not taking like the period and putting it in there. This number right here is always going to be 2 pi divided by the period. Okay? This one. I'm doing the same thing I did the last time. The difference here is they're not flat out telling you this is the amplitude, this is the period, so on. But the numbers are still right there. You can still pull them straight out. And based on the way they have this drawn or what they're explaining up there, you can either decide if it should be modeled more as a sine graph or a cosine graph. Okay? So what do you think first? Should I do sine or cosine here?
Sine.
Tangent? That's tangent. Here's the thing. Where are they starting it from? Are they starting it from the middle or are they starting it from down here?
They're starting it from
Where does it say it started?
well, it says that it's released at time. Oh.
So it's
Gosh.
It's released at 0, so it starts at the bottom.
Okay, so if it's it's pulled down and released here. So that means at t equals 0, it's down here. It's not here. If it started here, this would be when your displacement's 0, so it would be like the last one. Since it's starting at a minimum, that means I'm going to be doing a cosine. Yeah, that's all I care about. There's no vertical shift to this. It's just that. You could do it as a sine with it. Well, no, you really can do it with a sine shift. What's that?
Because the mass released at the time t equals 0.
Yes.
I don't understand. Why it's supposed to. That's 0.
Because like this position where it's sitting, like when they draw this line, think about this as like the x-axis.
Okay.
So for me to start this, guys in the back, shut it. If I pull it down here and release it, that means I'm starting it at a position lower than the x-axis.
Okay.
So the only way it can be sine is if it's starting at the x-axis.
Okay, would we get this picture with this like word problem? Or like what?
Okay. All right. So this right here, where they're saying that this is how far down you're pulling it, guys, this would be amplitude. Because it's not going to go beyond that distance. All right, so I pretty much know right now what A is. A is going to be a -2. Right? Because normal cosine graphs start at the highest point. Since this one's starting at the lowest point, that means it has to be negative as opposed to positive. Remember the B right here? B is 2 pi over the period. They tell you what the period is. Okay? The period is the distance or the length of time it takes to go from where it's starting up to its highest point, back down to where it started, which is 1 second. So that means B would be 2 pi over 1, which is just 2 pi. And that's it. So all the stuff that's up there, like the way it's worded, you just have to be able to pull out what the amplitude should be and what the period should be. So this should be y equals -2 cosine 2 pi t. And again, the difference between the one before this and this one is this one's starting at a minimum, which is cosine, as opposed to the one that starts at the middle, which is sine.